Alright, so we're going to do the problem that we did in class where we were trying to find the total force on charge 1 due to the other two charges in this equilateral triangle. So all the sides are the same and all the angles are 60 degrees. So first thing we do is draw in the direction of the forces. So the force on charge 1 due to charge 2, it's a positive charge. They're both positive charges, so it's going to repel it back over in this direction. Charge 1 and 3, those are both positive too, so charge 1 is going to get pulled away, or pushed away rather, from charge 3, so it's going to be down in that direction. Look for symmetry. Does anything cancel out? No. So now we need to find the forces. So I want to find the force on 1 due to charge 2. So that's K Q1 Q2 over R squared. So K is 9 times 10 to the 9. Q1 is 2 nanocoulombs. 2 times 10 to the negative 9 coulombs. Remember, nano is 10 to the negative 9. Charge 2 is also 2 times 10 to the negative 9. And on the bottom, we put the distance between them squared. The distance is 1 centimeter. And I'm going to put that into meters. 1 times 10 to the negative 2 meters. There's 100 centimeters in a meter. And I got to square that. So I get 9 times 2 times 2, so that's 36, times 10 to the negative 9 on top. 10 to the negative 2 squared is 10 to the negative 4, so I get 36 times 10 to the negative 5 newtons. The force on 1 due to 3 is KQ1, Q3 over the distance between those squared. And again, the distance is just one side of the triangle, 1 centimeter. So I've got 9 times 10 to the 9 times 2 times 10 to the negative 9 is Q1. Q3 is 1 times 10 to the negative 9. And the distance again is 1 centimeter. Got to square that. So I get on top, I've got 18 times 10 to the negative 9. On the bottom, 10 to the minus 4. So I get 18 times 10 to the negative 5 newtons. Alright, what's the next step? Well, I've got to find the total force. So I've got to add these two forces as vectors. So I need to break each vector up into components. So let me make my little chart. X component, Y component. So I've got F12 and F13. F12 is now horizontal, so that means it's got no Y component. And it's in the negative X direction, so I'm going to put a minus sign in front of it. And all of it's going in the negative X direction, so I'm just going to put down 36 times 10 to the negative 5. Okay, how about F13? Now F13 is going this direction, so it's going back in the X direction and down in the Y direction. So both of those are going to be negative. What are their components? Well, I've got to figure out what the triangle looks like. So if I look at it, here's F13. Here's my x-axis. And this angle is 60 degrees, so this angle, which is opposite to it, is also 60 degrees. So that's 60 degrees. If I want to find my x component, it's this side of the triangle. This side of the triangle is touching the angle, so that means it's adjacent, which means we use the cosine. So it's going to be 18 times 10 to the negative 5 cosine of 60. And the y component is this side, which is opposite to the angle. If it's opposite, we use sine. Okay, so the total force in the x direction, I add down the x column, so it's negative 36 times 10 to the negative 5 minus 18 times 10 to the minus 5 times cosine of 60. Cosine of 60 is just 1/2. So that's 36 and 9, which is 45 times 10 to the minus 5 newtons. In the y direction, I add up down the y column. I've got 0 minus 18 times 10 to the negative 5 sine of 60. Sine of 60 is root 3 over 2. I get negative 1.56 times 10 to the negative 4 newtons. And if I'm going to put that, let me put that in the same unit, so that's minus 15.6 times 10 to the negative 5 newtons. So if I were to draw this, it goes backwards in the x direction, it goes down in the y direction. I got 45 and 15. So it goes roughly minus 15.6 down. Okay, so here, the hypotenuse is my F1 that I'm trying to find. So I want to find the magnitude, and I also want to find the direction. So I need to find that angle in there. So to get the magnitude, you do x squared plus y squared is equal to F1 squared. So F1 is equal to the square root of 15.6 squared plus 45 squared. So that's 47.6 times 10 to the negative 5 newtons. And to make life easier, I just drop the times 10 to the negative 5 and put it in. If you want to be safe, put it in here. So put 15.6 times 10 to the minus 5 and 45 times 10 to the minus 5. All right, how about the angle? Well, opposite over adjacent is equal to the tan of the angle. So tan theta is equal to negative 15.6 over negative 45, which is plus 0.347. So theta is inverse tan of 0.347, which is 19.1 degrees. And so your calculator gives you 19.1 degrees. When you solve a problem, you're often asked, what is its angle with respect to the positive x direction? Or what is its angle with respect to the negative x direction? So if I look at my angle of 19 degrees, it makes sense that this angle in here is 19 degrees. So this is 19 degrees below the negative x direction. So 19.1 degrees below the negative x direction. Or if I wanted to refer it with respect to the plus x direction, I'd have to find this angle here. So it would be 180 minus 19.1. So that would be 160.9 degrees below the plus x direction. Okay, so again, when you're doing a problem and they ask you for what the angle is with respect to a certain direction, you need to figure it out by drawing a picture. So always draw a picture of your final x and y component so you know when you get the angle from your calculator where it's actually referring to.